So for this example, we are going to calculate the back EMF of an inductor. And this is as the inductor is turned off. So let's assume that we have a current of 5 amps initially flowing through a inductor with an inductance of 2 henries. And this is shut off. And so the current goes to 0 in 1 millisecond. So the question is, what is our self-induced EMF? So we know that we can calculate this by looking at L times the time derivative of the current, with the minus sign out front. And at this point, we can begin to plug things in. So this is a negative times 2 henries, which was our inductance, times our change in current. And let's just assume that this is uniform, and so we lose 5 amps. Note another minus sign in 1 millisecond. So this is 10 to the minus 3 seconds. And so if we compute this, is going to be a positive 10 divided by 1,000, or 1,000th. And so this is 10,000 volts, which makes this a somewhat dangerous situation. And so the inductor is basically acting as a 10,000 volt power source. And note that the direction here is positive, and so this is going to be in the same direction as the initial current. Right? It's going to try to replace the current that is dying off with this didt, and the self-inductance is going to drive a 10,000 volt voltage difference.